All right, so we're going to do a couple examples from section 9.1 in your book. These have to do with one variable equations. Some of them deal with fractions, which I know you all love very much. So we'll do a couple examples of that, and we will do this first example of a one variable equation that does not have any fractions. So when you're dealing with something like this is number 26 from 9.1. You got to remember your order of operations, right? Remember, you're going to do things within parentheses first. Your PEMDAS, if you remember, your PEMDAS is your key for order of operations, right? You do inside parentheses first, then you deal with exponents, then you deal with multiplication and division. Now, there's no preference between multiplication and division, but there is preference multiplication and or division before addition and subtraction. Okay? But multiplication doesn't come before division. They're really the same operation, so that's often confused. Multiplication and division kind of think of as one thing. Addition and subtraction think of as one thing. And you can always think of subtraction as the addition of negatives, and you can always think of division as multiplication by a fraction. So parentheses first, exponents next, multiplication and division next, left to right, whatever it is, and then addition and subtraction. So there's nothing to do within the parentheses here. There's no simplifications going on. But we want to get rid of those parentheses. So we're going to realize when you have something in parentheses like this, you're subtracting everything within that set of parentheses. So you're subtracting a 3a, and you're also subtracting a negative 4. And this is a common mistake. People will forget that when you subtract a negative, it becomes a positive. So when you write this, you're going to say 7a minus 3a minus a negative 4. So that's a plus 4 equals 12. Okay, so this is the most common mistake here, is putting a negative instead of a positive there. Be careful with that step. So we're solving for a, so we want to combine all the terms with a in them and put them on one side of the equation and put everything else on the other side. So we combine these two terms with a. So we have 7a minus 3a. So that's going to leave us with 4a. And then we still have the plus 4 equals 12. Let's move over here. Now we want the term with the variable in it to be by itself on one side of the equation. So we're going to subtract 4 from both sides of this equation. So if we subtract 4 from this side of the equation, we end up with 4a. If we subtract 4 from this side of the equation, we end up with 8. And now nicely, all we have to do is divide. We want the a by itself. So we say, what do we have to do to this to have just a? Well, we divide by 4. If we divide this side by 4, we end up with a. If we divide this side by 4, 8 divided by 4 gives us 2, and that's our answer. And we can easily check this by putting it back into the equation, the original equation, and making sure we get a true statement. Right? Well, if I put 2 in here, I get 14 minus 6 minus 4. 6 minus 4 is 2. So 14 minus 2 gives me 12. So I know that's the correct answer. All right, so that's a one variable equation with just one unknown. We manipulate the equation until we get that unknown variable all alone on one side, and whatever's left is going to be our answer, easily checked to see if that's correct. Well, then sometimes we have an equation like this. This is still just one equation and one unknown. We want to solve for y here. So if it confuses you when you have fractions and whole numbers together in the same equation, sometimes I think it's easier if you make everything into a fraction. Right? Now you can make any number into a fraction, right? Just put it over a denominator of 1. Right? So I'm just going to rewrite this 4 as 4 over 1. Didn't change the value, just changed what it looks like, because now I want everything to be a fraction. Same thing over here. I can put this 1 over 1 and make it a fraction. Now everything's a fraction. Just makes it a little easier to deal with. Because now what we want to do to get rid of the fractions is we want to multiply both sides of this equation. This is number 36. By the least common denominator. Okay, the least common denominator. So now we have denominators for each term. Right? We have a denominator of 3, a denominator of 1, a denominator of 6, and another denominator of 1. So the least common denominator is the smallest number that all of the denominators divide into evenly. So I think the easiest way to find this is you look at the largest number among the denominators, which in this case is 6, and you ask yourself if all the other denominators divide into that evenly. Well, 3 divides into 6 evenly, 1 divides into 6 evenly. So our least common denominator is going to be 6. Now the reason we do this, we're going to multiply both sides now by that least common denominator. And again, I'm going to write it as a fraction, just so everything's a fraction. Makes it a little easier to look at. So I'm multiplying the left-hand side of the equation by 6. I'm multiplying the right-hand side of the equation by 6. Now, after this step, all the fractions are going to be gone, and we're going to be back to where we were in number 26, just a nice one-variable equation, and hopefully easy to solve. So I'm multiplying 6 times this fraction. So you can either we know how to multiply fractions, right? The numerators, you multiply the numerators together, you multiply the denominators together. Now you can also simplify the fraction first to make your numbers smaller and a little easier to work with. If you notice that 6 over 3 is just the number 2, right? We can divide 3 into both of these numbers and make 6 over 3. Realize 6 over 3 is just the number 2, right? So if we do that, we can make 6 over 3 equal 2 over 1. And now it just makes our numbers a little easier to work with. So 2 times 2y gives us 4y. And the 1 times 1, that gets rid of the fraction, right? Let's put that back the way it was. Now also you can look at it as 12y over 3, which is going to reduce down to 4y anyway. And then 6 times negative 4 is negative 24. All right, so notice the fractions disappear once we realize what the least common denominator is and multiply both sides of the equation. We haven't gotten to this side, but notice over here, when we multiply by the least common denominator, the fractions disappear. And the same thing's going to happen over here. 6 times y over 6 is going to be 6y over 6, or y, right? 6y over 6 just becomes y. And 6 times negative 1 is negative 6. And now hopefully once we get to this point, you see it's just a nice one variable equation similar to what we did up here. We want to gather the y's on one side of the equation. It doesn't matter what side you put them on. I'm going to subtract 1y from this side and subtract 1y from this side. Okay, so if I subtract 1y from this side, I end up with 3y minus 24. And if I subtract 1y from this side, I end up with negative 6. All right. I want to isolate the term with the y, so now I'm going to add 24 to both sides. If I add 24 to this side, I end up with 3y. If I add 24 to a negative 6, I'm going to get a positive 18, right? Negative 6 plus 24 gives me a positive 18. And one more step, we divide by 3 both sides, and we get our answer of 6. Again, we can check this by going back to the original equation and putting that 6 in. 2 times 6 is 12. 12 over 3 is 4. 4 minus 4 is 0. So this side of the equation equals 0 when we put 6 into it. This side of the equation, 6 over 6 is 1. 1 minus 1 is also 0. So again, we can prove to ourselves that that is the correct answer. Okay, so one variable equation without fractions, one variable equation with fractions. We multiply both sides by the least common denominator to rid ourselves of those fractions, and then we solve the resulting equation. All right, so let's do one more here in section 9.1, just to solidify our knowledge of solving a one variable equation that involves fractions. So again, this is number 38. A one variable equation with fractions. We look at the denominators 3, 2, and 6. Again, we take the largest number and ask ourselves if the others divide into that evenly. This one does, again, so our least common denominator, again in this case, is 6. If the other numbers did not divide into 6, then take the next multiple of 6. Go to 12 and check. If that doesn't work, go to 18 and check. And keep taking multiples of the largest denominator until you get the smallest number that all the denominators divide into even. So just like we did before, we're going to multiply both sides of this original equation by 6. Again, I'm just putting it over 1 just so I have everything as a fraction. Now I'm multiplying this times this fraction. Again, the 6 over 3 becomes 2. So I'm multiplying this expression by 2. Right? 6 over 3 is 2. 6 over 3 is 2 times this 2x minus 3. Right? And 6 times 1/2, 6 over 2 is 3. Over here, the 6 over 6 is just 1. So 1 times 5 leaves us with 5. Again, if you just multiply across, you get 30 over 6, which reduces down to 5. And again, once after we do that step, we have a nice one variable equation. Now we distribute the 2. We're saying 2 times 2x is 4x. 2 times negative 3 is negative 6. We still have this positive 3 here. And we still have the 5 over there. And we want to isolate the term with the x in it. So let's add these together first. So we'll get 4x, a minus 6, and a positive 3 leaves us with negative 3. Now I'm going to add 3 to both sides so I can isolate that term with the x. So if I add 3 to this side, I get 4x. If I add 3 to this side, I get 8. And nicely, all we have to do now is divide both sides by 4, and we get our answer of 2. Again, you can put that back into the original equation and check it to make sure it's true. If we put a 2 into the equation here, we get 4 minus 3, or 1/3. 1/3 plus 1/2. So the check, let's write it out over here so we can see it. When we check it, we're going to get 4 minus 3, or 1/3 plus 1/2. And we want to know, does that equal 5/6? Well, we got to get a common denominator to add these two fractions, right? And the least common denominator, again, choose the largest number, 3. 2 does not divide into 3 evenly. So we take the next multiple of 3, 6. 6, 2 and 3 both divide into. So I can write 1/3 as 2/6. Right? 2/6 is the same as 1/3. 1/2 becomes 3/6. Right? And that does equal 5/6. So we checked it. We know it's correct. And we move on to the next problem. All right, so that's section 9.1.